Use cases. These are the use cases that we think at this point, or some of them, are most interesting. We've talked about some of these already. I'll close out on a couple of the other ones at the bottom here. So data center network virtualization at this stage, very well understood use case. I think we all got it. WAN network virtualization, this was the Internet 2 conversation. Again, I think a pretty well understood use case. The role of the load balancer, we were just touching on that. We call something a cloud gateway use case, which is effectively bridging between this use case and this use case. So how do I take an MPLS-based or OpenFlow-based network or WAN network virtualization solution and tunnel and link that together with a VXLAN-based data center virtualization solution? You need something to do that use case. But these are the three that I wanted to kind of close on. The first is analytics, and I teased this out up front and said, I'm hearing more and more people, really in about the last 6 months, talk about this. How can I take production traffic and either use an out-of-band network, tapping that traffic to an out-of-band network, or do it natively within the production environment and get the volumes of data I want out of the network, but only the pieces I want. You know, you think about what that problem statement looks like, and it kind of looks like policy-based routing on steroids. This is really hard to do using traditional forwarding, so you've got these different companies out there who have built custom-built solutions designed specifically for this. But it's an excellent OpenFlow-based use case. It's a very good OpenFlow-based use case. Similarly, you know, when I ask people, particularly in sort of mid to large-sized enterprise organizations, where's the ugliest part of your network? You always, in my mind, hear the same answer, and it's really one answer, but it's got three sort of heads. One, the internet edge. Two, the services layer in the data center. And three, and usually worst, the extranet. Right? I got all these different services that I got to stitch together, firewalls and load balancers and IPSs and caches and forensics devices and DLP devices and all of these things. And it's a royal pain because they all want traffic handed to them just a little bit differently, and all the network really wants to do is send it to the destination. So I have to do all sorts of goofy things, stitching VLANs, PVR, having something that's really not a very good router participating in my routing protocol to try and make the network do something it doesn't want to do, which is not forward the packets. Again, perfect use case, we think, for OpenFlow, right? Here, I already today effectively hand steer that traffic through that environment. So I already know what the policy is. I just need a better way of instantiating that policy in the environment. And again, the good thing I like about this and this is relative to this and this, it's a very small part of my network. Not a lot of physical devices I need to do this on to get value. So I can build a business case that's credible to, you know, the powers that be in the organization to get something installed relatively quickly, get my team working on it, it's a big win, and then we can start looking at some of these larger use cases up on here. The last one I wanted to mention, packet optical integration, and I put this as much as anything to be mildly controversial. You know, there's been a big push over the last while, I don't know, decade, to try and drive an integration between the optical layer and the packet layer. And SDN kind of makes people like me say, why would I ever want to do that when I can effectively get that same benefit just using software? Right? Why do I try and drive something that is a layer one physics, you know, very quirky problem and tie that to a router? Let's just keep those things separate, use software to control both sides of that. And there's work at ONF on this very problem statement today. I think that notion of packet optical integration is going to end up being very dated, and we're going to use software to provide that same notion. It's exactly the same conversation as we have about integrating compute, network, and storage into a service, just at a way lower level in the organization. Right? They don't have to be the same thing. They just have to work together and speak the same language.
Should we ask the guys what number 8 should be?
This is the question here is, and this is why we thought we would close here and then go to open, and I took a little bit longer than I meant.
We've got 10, so we'll get 12 opinions.
We at 12, we'll have to put like 2 or 3 more blocks down here.
I'm a big fan of number 6.
You're a big fan of number 6.
This one?
Yeah, but that's because I worked for a bank, and guess what I got?
Yeah.
Big extranet. I have several extranet clusters of multiple layers deep, and each one's got different devices on it and service injection.
I think this one's pretty cool. I think what's interesting here is not only the question of how do I start doing the insertion, but then you start to say, can I start taking can I take information from one and share it with another in a scalable fashion? And then can I start to pull some of those services out and have them natively run in the router? You know, forwarding packets is something that routers do really, really well. Doing layer 7 services is not.
Do you want one more?
I would love one more.
Low latency HFT with zero multicast.
Low latency.
Unicast stream replication with an open flow rule. No multicast overhead.
Interesting.
Which would go back to your banking example, right?
Yeah.
Yeah.
So if you imagine today, how much money and time and pain do we spend doing rendezvous points and automatic failover and low latency
Sparse mode,
multicast and HFT switches? But I can just have an open flow rule that says, see this, and then I have to write software that streams out in multicast. Why don't I just use a multicast IP address with an open flow rule, and as it comes into a switch,
You can
replicate
spray up.
20 ports.
Yeah.
I've got zero multicast.
Yeah. Yeah.
I've got
No, that's a
rendezvous points.
Would certainly lower your operational cost.
PIM is basically just policy construct.
And let's face it, all of those HFT switches are doing what? They're only doing one thing.
Yeah.
True, Chris?
They move data from one ingress port to lots of egress ports.
That's it.
Yeah.
They're not dedicated. They don't do anything else but that task, the multicast feed.
Oh, yeah,
Yeah.
It's, that's why QoS doesn't help.
Yeah.
Because everything's important.
And right there, you've just turned up,
For market
just
data.
turned over a whole market of high profile, high profit, high revenue business opportunities with one.
Still have to be able to make that happen in a fairly competitive, low latency environment, though.
Still has to be a low latency switch, but yeah,
Yeah.
this thing over here, see that chip in that VDX 3770?
Yeah.
3.5 microseconds, and it's not even they're not even trying hard. You can get it down to 2 microseconds on a smaller chip.
Which for a modular chassis isn't bad.
Well, it isn't bad, but you know, I think that space can become highly competitive. There's a lot of other players in that market that you know, it's a race to zero for speeds right now.
Mhm.
You know, coming down to literally lengths of cables.
Most of the latency in those switches is in the multicast handle.
Not everyone's using multicast to accomplish what you're talking about.
No.
So
Good use
Okay.
case. I like it. What other use cases?
And it's a point use case.
Yeah, and
But
again, that's the thing I like about those kinds of things is, you know, big network-wide transformative stuff is really exciting and cool and very, very hard to see the road from here to there. Right? You need the little micro things that can help us
Yeah, I
get
think that's the
started.
insight you're bringing. It's very difficult to get these one-offs, but now you've got a mechanism or an architecture that can facilitate that, right? PBR and steroids is a good way to describe it.
Well, look at DDoS mitigation. I mean, it's trying to achieve PBR. You're trying to
Yeah.
steer a particular identified stream of traffic off to a device and decide to forward it or not. And you can run BGP to do it. You can do PBR to do it. But you know, if you have a device that's capable of doing that, it's already in the forwarding lane.
Yeah,
Just
or lawful intercept. You're looking at a specific VoIP conversation between you or I, or a specific financial transaction. You know, 1 in a million packets. I mean, how do you do that, right?
So I'll give you one that's much less corner case in that sense. So today, if you're your typical enterprise, you've got thousands and thousands of access points. You've got the global view. You go to one page. There's everything. You want to apply policy to everything, you click a button and apply policy, right? Go to the wired network, which is eventually just going to be backhaul for wireless
Right.
in an enterprise.
Fair.
And you go program, 3,000 to 4,000 distributed BIOSes. So virtual stacking is not SDN. There's a hard cap there. So this idea that, it doesn't scale in the enterprise when you're really talking about, fairly low aggregate bandwidth. It's the management problem just completely. So we tunnel all traffic through a controller and a wireless. Obviously there's some emerging stuff where it pushes forwarding to the edge and the AP.
Right.
But for the most part, it's a total tunnel there. I just want one packet to go there. I'm gonna look at the headers, do whatever I want with it.
Push it
And
back.
that's policy, and that bump in the wire, that's not there today. So, the bigger picture is the ability to apply policy. And we've got a roadmap, because we just look at our wireless and compare your CLI that you just telnetted to, or SSH to the wireless controller GUI. It's bizarre that it's taken us this long.
Yeah, the controller
Why
analogy
this
is
so
absolutely.
nice and this one's so unmanageable.
Okay. True.
Questions, guys? Comments? Thoughts?
one quick question on the load balancer. You were kind of saying, well, you've got to go through these crazy hoops to pretend you don't, to deal with the fact that you've got multiple layer 3 hops. But I mean, isn't that problem already solved? I mean, does it solve having a load balancer with a non-adjacent host, is that still a problem in the industry for people? I thought that was kind of pretty. You said you have to do source NAT, but so you have to do source NAT. Is that still a problem for people?
Yeah. So there, I'm trying to figure out which layer to answer your question at. So let me answer it most directly on source NAT. So why does source NAT suck? Source NAT sucks because you lose visibility into who the source IP is. So if I'm doing any kind of geolocation, it sucks, right? Everybody's going to look like they come from the load balancer. So selective add insertion breaks.
Kills all my analytics.
Kills all your analytics.
But the X-forwarded
breaks.
4 doesn't.
So you start getting into, okay, now I need X-forwarded 4, that I've got to start injecting these things.
Yeah.
Is this something that we have come up with mechanisms to do? Absolutely. Absolutely. I mean, layer 3 DSR is a good example of that, right? I want to do direct server return with layer 3 DSR. We partnered with Yahoo and some others to go and do this.
Yeah.
And yeah, I put a kernel hack into my server and I can do layer 3 DSR.
Puts handcuffs on you from actually leveraging those higher level features.
Yes. And I now have to deal with, I've put a kernel hack into my servers, and it's kind of ugly. So does it, that's kind of why I was saying in my mind, it's not sort of, oh my God, the simplicity argument is going to be the reason people go there. But I suspect once we get there and look back, the simplification of your day-to-day operations is going to be perceived to be as valuable as some of the other reasons why you did go there.
Okay, you're saying when you get there, you can look at it again. And
you're going to be like, wow, my config's about a
yeah.
third as long as it is, and I don't have to deal with these goofy, let's try and forward packets around, and shoot, I got to screw with layer 7 headers again, and all that kind of stuff. It just goes away.
Okay.
Not enough to motivate you to do it, but pretty interesting along the way when you get there.
I think the operative word there was hack. We can always hack anything in networking, right? I think we've got lots of examples of that. I think this is a much better approach to some of those problems.
Yeah,
right?
sure. I guess it's one of those hacks that has been done a long time ago, and I guess it's a chance to unravel the hack. That's a fair argument.
Yes. Yes, absolutely.
So are we on the right track here, guys? I mean,
Yeah, for me.
yeah,
Yeah,
good to hear.
except for the multicast one, which I only figured out yesterday.
Greg's point of view, number 6 being that extranet stuff. I've got plenty of fingers in interesting areas, and it's trying to get everything they want done.
Right.
It's either a headache or we make compromises.
Yeah.
We shouldn't have to make
The
compromises.
biggest thing about use case number 6, because I've done a lot of work in this area, is change control. You can actually go in and reprogram flows without flapping route tables or spanning tree, or
Refreshing
pick up a
BGP.
flow and explicitly define it.
One thing which is kind of may or may not be appropriate, but there's a lot of contention out there in people who don't know how to set their alarms. No, there's a lot of contention out there in vSwitches. Is that yours?
No, it's not.
Nobody wants to leave and admit it's their car, right? So.
I gotta go, guys.
Actually, what you got is a whole bunch of people upstairs hitting the button.
What we have is software definition of the topologies in the virtual switch layer, but we don't actually. Maybe I'm completely wrong. We have this already, but the notion of using OVS or an equivalent to actually as a container for these flows, where we have an SDN controller that, whether it's pushing down flows and actually instantiating and controlling the flows in your physical network, but then making sure that there's a consistent implementation all the way to that vSwitch layer.
Yeah, you are absolutely right. What's interesting is if you watch kind of what's been happening over the last 5 years, specifically within VMware, but it's happening within Linux as well, is the going back and forth that VMware's been having on allowing people to stick stuff in the kernel. Yeah, you can put it in. No, you can't. Yes, you can. Well, you can if we like you, but you can't. And they face a lot of anxiety around the openness, if you draw the analogy all the way over, that Microsoft took with the browser and all of the security challenges that created as a result of that. So they're trying to be open enough to let you stick things in there, but being closed enough to not create a security problem. This makes a whole bunch of that problem go away, because I don't need to stick something in the kernel as some sort of custom safety analytics thing. I don't need some sort of custom tap that I've stuck into the kernel. I'll use exactly the same policy process to go and hook and replicate traffic out of that environment as I do in the physical environment. OpenFlow neutralizes some of that mucking around in the kernel. It doesn't get rid of all of it, but it certainly does drive towards a level of consistency between those two that I think will change how we think about the difference between a virtual switch and a physical switch. And in the direction that people don't tend to think about. I mean, most of the time, that's a conversation about everything driving out of the physical network into the virtual network. I think some of that starts to come back the other way. Other questions? Oh, so Lisa is over there. Lisa wanted me to talk a little bit more about this one. So let me just
Everybody has their own pet.
touch
I'm holding back, but fair enough.
on that one.
Yeah.
Powder dry.
So I somewhat hinted at this earlier, but let me be a little bit more direct and bold on this. When we think about the application space, network application space versus the controller space, and some of what I was saying there earlier, I made a comment about the long tail of applications, right? And that's where the innovation can come. So what does that then start to look like? Well, I want a programming environment where I can create little applets, right? We have in our platform OpenScript. You've got things like F5s and their iRules out there. The notion that this, as I said before, the application delivery controller platform becomes this sort of general purpose network services box. You want that kind of flexibility to custom program these individual long tail entities. When you start to see then, you look at that and you say, all right, so we've got this today, and our platform, of course, very focused on high performance, low latency. You can real-time analyze layer 7 data in the network, so you don't have any of the latency concerns in some of the L7 use cases of threading things up to a controller and then threading them back down. It's actually credible to have an inline layer 7 network application. Starts to say that an ADC looks an awful lot like what we've historically called a controller. So you think of the evolution of that space. Does that mean ADCs become the controller market? No, but I might postulate to you that we'll see what we think of as a controller today kind of start to move in a couple of different directions. There will be things that, generally speaking, don't handle data traffic. Maybe they handle control packets. Maybe I send ARPs up there and they do network discovery, but they don't handle real live data. And those will look an awful lot like what we today think of as a network management platform. Then there will be the other thing. There'll be things that handle data. And we all know that having something handle data effectively means putting it in line. And putting things in line is scary. We don't like putting things in line. My favorite example about this is the DLP market. I mean, you looked at that problem statement when it first came on, and I was involved with some of the big banks when they first stuck those things off a span port, and you saw the stuff leaving their environment. And it was horrible, nasty stuff leaving all the time their environment. And the DLP vendor said, great, if you put it in line, we can block all that stuff. And everybody went, oh, no. You are not running traffic through my box. This, like I said, is one of two things that has been in line long enough for us to trust it to touch layer 7 stuff. Firewalls, load balancers, the two things. So if I have the need to touch data traffic and therefore am in line as a controller, I think you're going to see these platforms take on more and more of that role. So they've already got the programmatic control on the top end. I can write a script, I can write a program into it. They already are trusted to handle traffic. They can do layer 7 replication. Pretty cool platform.
Well, I think even an extension of that, we're in the land of chipset design, and we look at what a EDA cluster goes through. If you take some of the more abstract parsons out of it, there's different cycles in chipset design that go from breaking a job apart, transferring libraries, creating grabbing a bunch of code, pushing it out, and then culminating in these concatenation jobs. And the network itself, being able to, there's certain times when you want to have your network structured and optimized in certain ways for the job, whether it's ingesting the data, egressing the data, linking flash memory spaces together with some servers.
Right.
Perhaps when you look at job controllers or even file systems, like Luster, being able to provision. Now that the network itself is a mid-plane and a large server in some case, to be able to actively provision to meet the SLAs and needs of the app.
Yeah, absolutely. Absolutely. I mean, yes. And then you say, okay, I need something with enough intelligence there to understand the context of the conversation that's happening within that midplane.
Yeah.
Yeah.
And right now, we just kind of say, the best case, we throw money at it,
Yeah.
you know?
So this conversation for me continues to drive home that notion that the controller market, you know, we've seen some of the announcements that have come out recently where everybody's talking about, I've got a controller now. I think that's missing the boat, right? It's about the use case and the application. That's what matters. And we as an industry need to drive a level of standardization on those northbound APIs so that we can ensure that those apps, you know, there's a good marketplace for those apps and we're not ending up creating inadvertent lock-in by moving the platform, if you will, from the embedded OS just up to some particular vendor's closed controller environment.
Yeah, I don't agree. You have to have a platform before we start. I think the industry is going to come together and develop. I think that'll come. If it doesn't come, you know, out of whatever ecosystem comes along, then I think we start worrying about it. But I really think we've got to get the ship in the water, get the platform there, and then horizontalization starts taking place because we have proper abstraction in place.
I agree, but I think we got to go in with the abstraction on both sides. The abstractions, my comments are not to say platforms are bad. My comments is to say closed platforms are bad.
No, totally. Well, and you have REST. We're starting to see it, at least some frameworks around the RESTful API. I think that's encouraging.
Competition is the key. Competition is good. Other questions or comments, guys? Does this sound like we're on the right track? Do you guys feel like we're doing the right thing?
Definitely.
I say
As you say, the big ones are the top line, but that's going to take a long time to generate.
So I'll ask a very specific question. You talk about applications being the missing piece. What work is Brocade doing with key application vendors or application use cases to complete the puzzle?
Stay tuned.
Early days.
I was
If I
talking,
didn't tease enough of that out there, stay tuned. You'll see stuff from us there shortly.
I was talking to
What's your
Carrot.
definition of short? Chipset design short or software design short?
Software design short.
Okay.
Yeah, I was talking to
Software
Carradine earlier in the week. Carradine, they're the people who design MPLS path computation software, and they're the sort of people who are going to develop this WAN network virtualization and the edge integration, packet optical integration pieces, because they're already doing it today, have been doing it for a decade.
Yeah.
And then they're
Plug-in.
Sorry?
It's just a plug-in for them at that point.
Exactly.
It's a little more complicated than that, but conceptually, yes.
Conceptually, yes.
Conceptually, some of the execution is very different for them because, you know, they've got all the maths and everything to do path computation and network analysis and device awareness and stuff like that. But they'll also be able to do multiple devices. So it's not possible. One of the things that I'm starting to realise is that vendors like Brocade or even Cisco's, it's not possible for them to develop control software when most of the carrier networks or most of our data center networks are multi-vendor. We're going to have to look to a third party to provide a lot of those applications because the vendors can't. In your data center, it's not all Cisco. It's only some Cisco. There's still 20% of it's not Cisco.
In our data center, it's all Brocade.
Yeah,
So,
yeah, sure.
Well, you still see in my data center. I still have SRX files as well as ASAs, as well as McAfee enterprises, as well as IPS servers. I need to orchestrate all of those, or they all participate in the open flow. Therefore, I need to be able to have a system that actually punches all of those and recognises them reliably. Right.
Yeah.
So you can go to Cisco and get their OS controller platform, you know, or use 1PK, but an application that Cisco's has never ever, for example, demonstrated a willingness to work with anything but themselves. That's not very useful when 20% of your network is not Cisco, and there's nothing you can do to change that.
I think a lot of networking vendors will always work in their own best interest. And if they don't, they go out of business. But absolutely to your point that we have to have a unified management plan or a and not to get stuck in the standards bodies, but to have a functional interface exposed to our applications.
And this is the open flow and northbound API discussion.
Yeah.
Yeah. I mean, frankly, if Brocade wasn't acting in their own best interest or driving people to consume Brocade, I'd be worried about investing in them. You know, well, buying their product, buying their stock. I mean, they're their company and they're going to try to drive people in their own platform, rightfully so.
Things, and network management platforms that were made by vendors were ultimately never successful. So Bay Networks had a very powerful.
I mean, Cisco Works isn't successful.
No comment.
No.
Sorry, couldn't resist.
Slow pitch right down the middle there.
Yeah.
But I think that being said, this is embracing horizontalization. This is embracing that, yes, the software is going to be the value in the next X years, plug in whatever that is. And we've got the roadmap because it's the x86 industry to some degree. And then how can we shrink that timeline of evolution because we stalled about a decade ago.
Anthony, you're
Maybe
going to
this
say something.
unlocks this.
No,
No.
All right.
just typing some stuff.
Excellent.
No
But
worries.
this stuff's I'm grasping on the edge of losing my mind. It's just mind-blowing. For me, it's mind-blowing stuff, and it's these guys have more experience, and I'm probably newer to coming to this, and it's actually this is actually a use application for it, where I can see I can actually marry up one of these scenarios to my existing infrastructure and how
Okay.
I can leverage it where possible. So it's been great. Thank you.
Yeah, and that's where the traction comes. Yep.
Awesome.
Good.